All right, so in today's video, I'm going over a pretty straightforward tutorial. It's going to be showing you how to use a point attractor, a double point attractor, and showing you from the beginning for those of you who are fairly new how to use this. Now, if you don't want to watch the whole tutorial, you can always go to my website, download it right away, and see how things plug in so you can learn that way. But if you want to see how it all comes together from beginning until this, I'll show every single step. So if you have any questions or you're excited to learn a few more tips and tricks, even if you're experienced, you may learn a few things here or there. So with that being said, thank you very much for being here, and let me show you how to create this. All right, so the first thing we'll start with is going to be a plane surface. Now this is going to be more of a explanation and showing you a few tips and tricks for you to learn Grasshopper and take advantage of what Grasshopper is good for. So first, when we bring in a plane, we can do that in different ways. We can extrude a curve. We can also create a plane surface. This will let you create a surface, but you have to tell it in which direction. By default, it's going to be created in the XY plane, and you can see that here in the plane input. Typically, when you bring in a component, you're going to have things already plugged in, or there's going to be defaults built into the component. So what you can do is change them by, let's say, bringing in an XZ plane. And when you use this plane, it will change it from the world XY to this XZ plane. And we can also change that location. So if we wanted to, we can set a point here in Rhino, go to a point component inside of Grasshopper, set that one point, and then we can change the origin of where that is located. That will also be tied to the Rhino geometry, so we can always move this around. What I like to do though is do things fully parametric, so when you go and download the script, it'll be working right away. Now you can skip this entire tutorial and just go to my website and download the script if you don't want to see how it's created and you just want to see how it's plugged in and use it right away. But if you want to learn a little bit of how this is going to be created, I'm going over all the steps. So first thing is I'll delete this point. We're just doing it in the origin plane. It's going to be at 0, 0, 0, which is the origin plane here. And the X and Y size we can change. So let's go to the X direction. When you double click here and plug in any number, you'll get a slider. I'll copy it. I like to slide it down, tap Alt to create a quick copy. You can also Control C, Control V to create that. Now let's extrude this up. Now in Grasshopper, when you have a plane, you have the ability to subdivide it. Now by using the default components that come in with Grasshopper without having to download any other plugins or additional things, the most simple way that you can do a subdivision is called isotrim. Isotrim is useful because you can plug in this plane into the surface, and the domain is how you want to subdivide it. Now what's kind of unfortunate is that when you bring in isotrim, you also have to bring in another component to pair with it called divide domain squared, which it would be nice if they had isotrim with this already built in, or a different component like isotrim 2 that already has this built in, but it doesn't. So we'll take this plane, plug it into the domain, the segments into the domain input, and you'll see that it will subdivide it. Now you'll also see that it's kind of glitching out here, and that is because we have the plane that we originally created and the surface here overlapping. So we need to hide this one, and you'll see that it's subdivided already. Why? Because like I said earlier, there's going to be some defaults in the U and V for this component, which we need to change. So unless you like 10 and 10, but the point of using Grasshopper is that you can change the inputs. So to create a custom slider, here earlier I showed you can just type in any number and create it, but you can create a custom slider. Let's say 3 less than 15 less than 25. And when you look at the slider, it'll say the lower limit is 3, the upper limit is 15, and it's set at, or 25, and the value is set at 15. So now we'll take this, copy another one because we need to change both the U and V inputs. And notice that now it divides it by 15. Now, depending on how your surface was created, your U and V may vary. So just pick a subdivision that you like. We'll keep it around here. So it's going to be 5 and 10. The next thing we're going to do is now evaluate where the center points are of this, because we're going to be using a point attractor, only one first, and then we're going to be adding more. So starting with the surface, we need to know where the center of each and every one of these is. So we'll take that surface, bring in an area component. And an area component is useful because not only does it give you the area of each rectangle, which is really useful. In some cases, you actually want to know the area. And we know that the area is the same for all of them because we evenly subdivided all of them. The other useful thing is that it gives you the centroid, which is the geometrical center of the surface. That's useful because now what we're going to do is create a point attractor, and we need to know the location of all of those points so we can create the dynamic pattern that we're looking for. And that'll make more sense once we bring in a separate point that is going to be what it reacts to. So when you create a point attractor, first you need the grid of the objects that you're trying to do the pattern to, and then you need the point, which you can do that within Rhino. You can just create a point, move it up and down, and it'll react to that. Or if you want to do that parametrically, we can bring back the original surface. Now we're going to, give me a second here. Now we are going to create a point. Now, if we hide all of this, so select it, I like to middle click and then disable preview. That way you can disable the preview on more than one component at a time. With this plane, we're going to go to a component called MD slider. Notice that when you look at an MD slider, by default, like in the other ones, it's going to have a number set. It's going to be 0.5 and 0.5, which means the center, if this is 0 to 1, 0 to 1, it will be in the center. Now we need to go to evaluate surface. This is going to allow us to create a point on a specific surface. Now we need to take this plane, plug it into the surface, and then this 0.5 and 0.5 MD slider and plug it into the point. Now, by default, when you look at it here, it will move it 0.5 and 0.5 relative to whatever units you're using. Now, for it to look at this entire surface as 0 to 1 and 0 to 1, similar to what you see in the MD slider, we need to reparameterize the surface. What does that mean? It turns this surface, when you plug it into the surface input, as viewing it from 0 to 1 and 0 to 1. So now we have this point. that is in exactly the center. So similar to the centroid, is going to do in 0.5 and 0.5. But now we can move this around relative to the slider here, and we can move this around. Now, why is this useful and why is this cool? Because we have this plane. We want to create a point that it reacts to, and this is one way that you can create a point attractor on a specific surface. So this is going to be what the entire grid reacts to. Now this is created on that initial plane, so we can now hide it and bring back the isotrim subdivided surface. And notice that now we have this point and also this frame or this construction plane perpendicular to the surface that we can use to react to. Okay, so with that being said, let's move on to, I baked it here, that's incorrect. We're going to preview the points. Now, what is a point attractor useful for? Well, when you have a point, it needs to react to the entire grid, and this is how it reacts. How close this point is to this one. Let's say it's 5, this one is 10, this one is 15. So that is what it's going to react to. And we can do that by bringing in a line segment. So there are different ways that you can use a point attractor, but this will help you visualize how this works. We'll start by plugging in, well, creating a line component that starts at a point and ends at a point. So the first point is going to be the point attractor point. And the end is going to be not just one point, but all of these points. So the centroid into the endpoint. Notice now that that is what we're going to use to create the point attractor. So depending on where the point attractor is created, these lines are going to vary in size, which will allow you to vary the number and the distance to use for the point attractor. So with that, let's now bring in the length of each line segment. Now notice that they will vary. So the first one is 195, the second one is 169, the third one is 144, and they will all vary because they are all a different distance from that exact point. So to visualize what this does is, without changing the numbers of the length, we can now extrude this surface. In which direction? Let's go in the negative y direction. Why? Because here we'll see that the y direction is going in this side and we want it to go the other side. So we'll go to unit y and then negative. And so now if I use all of these lengths and plug it into the factor or the number input for the vector, it will now extrude it like this. And if we want to see how it changes, well, we can move this point attractor and see how the entire pattern is now reacting to where that point is located. And to see it visually, you'll notice that where this point is relative to that point is longer than where this point is relative to this point. So you'll see that, well, this box is going to be longer than this one and longer than this one. Or this one is closer to this one than to that one, so this one is longer. And that is the real power of using parametric tools, is that you can evaluate multiple objects at once to create a dynamic pattern like this. So moving this to a specific location, we can also visualize this a little bit better if we go to a custom preview. What does that do? It'll color your object. Now by default, you get this pink color, but we can also bring in a color swatch and change that by simply changing the color here. So let's make it something kind of colorful here. Okay. So now you'll see that, well, I want to be able to control the length. I don't just want it to be dependent on what length this is. I want this one to, or the maximum to be 5 feet and the minimum to be 1 foot. How do we do that? Well, before that, I'll show you that if we keep increasing the subdivisions, it will still do that because it will evaluate relative to the entire grid that we already had. So now let's figure out how to change this so we can control the minimum and maximum. Let's move this down here and keep things organized. Now notice that the length, the largest number is 176, and we don't know the smallest number, but we can reconfigure those and be able to pick the smallest and largest number. So that's going to be with remap numbers. And when you do this, you're going to bring in 3 components that will allow you to do that. Remap numbers, bounds, and construct domain. So these 3 in conjunction and all put together will let you pick the smallest and largest number. So this is how things plug in. Length goes into value. This lets it know all the numbers that we have originally. Length goes into bounds, which lets it know what is the largest and smallest number. So here now we know that the smallest number is 2.9 and the largest number is 151.65. And that will depend on where the point attractor is and the length of each line. So we'll plug in this domain into the source. And now I'll actually put this up here even though it plugs in down here. This is going to be where you plug in the smallest and largest number. So let's go here to 24.000 and create this twice. So I'm just going to plug in the same number, 24 and 24, into the start and end, and you'll see how we're going to change that, and change the domain, or plug in the domain output into the target input. So that is what we're targeting, is being able to pick the smallest and largest number. We also need the minimum and maximum number, and we need the original values. And that will let us remap the numbers. So notice that if we go here to mapped, they're all 24 because both of these are 24. And if we plug this into the Y value, well, if our minimum is 24 and maximum is 24, then they're all going to be extruded the same. But if we want the minimum or the start to be 2 and the maximum to be 60, now we have the control as to what the min and maximum are. And conversely, we can now swap these if we want to and do the opposite, or just lower this number to 20 or to 2. Let's lower this to 2 and then raise this one. And now it will do the opposite. Whoever's closest to the point is going to be the largest number. So this allows you to have control as to how you want the pattern to change. And in this right now, what we're talking about, we're just talking about extruding. In some other cases, we're going to talk about offsets, or we're going to talk about scaling. So this is the most important idea, is that a point can be used to relate to the entire pattern and how close it is to the grid, and then be able to do any type of modification. In this case, we're extruding those surfaces, those subdivided surfaces, which are these, in the negative y direction, so opposite to the positive, this way. And we're using remap numbers here to be able to change and update what these numbers are for whatever you need. So now in the next portion, we're going to see how we can take this modification and change it further. All right, so now that we have this done, you're going to be asking, okay, well, that's one point attractor. That's fine. But I want to have more than one point attractor. So let's change this number so it's a little bit more drastic here. Okay, I want 2 point attractors. So what do I do about this? So what we need to do is the exact same thing that we did up here, but we're going to add the point attractor. So we'll take this, copy it up. Now if we look back here, these two are the same. So let's switch this one up and go to the opposite corner. We're going to evaluate all of these numbers again. So we'll take the length and we're going to use this point. We're going to now have the minimum and maximum be the same. And we're going to now add. So we'll take these two. We got the length. We're going to now add those together. So I'll double click here on the length output to create a relay. Relays are useful because we have one output going to 2 different places when you create the relay. It lets you move it over and now have the ability to add another set here. So let's go here to plus and we'll add this length and this length. What that's going to do is, for those numbers, it's going to add them together and now give you the ability to pick 2 different points. So now those are working together and we can see that if we move this one to, let's say, the opposite side, now we're getting 2 different point attractors that we can move around and have the entire design change accordingly. So it's as easy as copying these 3 or these 4 components up and then just changing that one and make sure that you add those together. So let's bring this down, bring this down, and now these are going to be the 2 point attractors. All right, so now that we have this, let's see what else we can do, because right now we have just done extrusions and I feel like some of you who are fairly new are going to say, okay, I understand how that works with extrusions. The thing is, the same way that it works with extrusions, it works with everything else. But there may be some things that we need to adjust. Let me show you what I mean. First, we'll hide all of this. So select everything, middle click, and disable preview. Let's go back to this. Now, do we need to preview these points? Not necessarily. Those are just there to be able to evaluate where the points are and how far they are to the original points. So we can hide them. Now we're going to take the surface and offset the curves that make up that surface. So this surface has an outside line segment, and that outside line segment can be offset. Now we don't necessarily need to extract the curves because by default, when you offset a curve, it's just going to use the curve that is the outside of it. But the issue is that notice that it offsets to the outside. So now we need to bring in a negative component. And by default, this one's actually empty. So sometimes in the case of negative, we need to use a slider here. So let's go here to 3.5000. And notice that now we have the ability to also, if you create a slider and you use whatever decimal points you use, it will bring that in, and that lets you be a little bit more precise. Notice that it's offsetting all of them at once, which is okay. And we can also create a frame between the two by doing this. Now, the way to keep things organized, I personally like to just copy this. So do two offsets, one to the inside and the other one offsetted by 0. This way, it actually keeps things clean because it's using the same two components. And so this one, it's offsetting it by 0, but it keeps the offset curve. And this one, it's offsetting it by this amount. So by 0, it keeps it the same. And then this one is going to be offset. Also, this gives you the outside curve location where this one gives you the surface. Now we can use boundary surfaces between this one and this one. And if we hide the surface here, notice that now we get these offset frame boxes, which is what we could use if we wanted to. Instead of using just those surfaces, we can just use this to extrude and create the attractor surface. Now we need to be careful because notice that I plugged it in from the output into the base input. This is going to cause issues because that's going to be a grafted set. So it's going to double the work that it needs to do. And you need to make sure that you flatten the input so you don't get this issue. So let's let it recuperate here, and then I'll show you how to avoid this issue. Notice that now it kind of worked. Here's the thing. It caused some issues. Why? Because this, when it's a dashed line, it is a group of them, a set of them, and it's doing twice the work because each one is separate. So it's doing this way too many times. So what we need to do is make sure that when you see that dash line and this dash line, we're going to flatten the output. And now when we bring this back, so before you even plug this surface into the extrusion, before the extrusion was a flattened set, so it was fine. But since it was grafted, it was causing issues. So flatten the output, plug that in. And notice that now it's using that frame that we created, which is here, to create the extrusion. So what we need to do now is this. To see what else we can do using a point attractor, we know that if we offset this frame far enough, let's say if we keep going and going and going, the frame is going to disappear. And it disappears at around 5. So 5 is the maximum number that we can offset this. So using a point attractor, we can create a minimum and maximum number to create some variation on the offsets. If you like them all being the same, that's fine. But here's what we can do is going to move this over here. Since we already have a set of numbers and a way to remap them, all we need to do is copy this. So we're remapping the numbers again, but this time not for extrusions, but we're remapping them to offset the frame. So let's say here the maximum is 5 and the minimum is 1. So now it's going to react to the point attractor. So now the point attractor also determines how big the offset is. And so we can use this to notice that if we also go here past the maximum, well, it's not going to offset it correctly. And maybe that's something you'd might want to do is some of these are going to be solids, and then as they get closer or further from the point attractor, you'll see that now it gets opened up. The only issue is that this offset, since these don't work, it's going to give you an issue telling you that some curves offsets failed because it went past the maximum. So this is where you'd want to just go, let's say go 5 here, or 5.1. Let's make, let's see, 5.1 I think was the max. So the furthest one is 5.1. We can probably go even 5.2. And notice that now this is still working. So we're remapping them again to create the offset. Now we can also do the opposite. So like I said earlier, we could just flip these, or change the number on this one and this one to match whatever you're trying to do. So let's go here to show. All right, so now that we have this, that's going to conclude the tutorial. Now, I know some of you are pretty experienced with Grasshopper, but I also get a lot of people asking me fairly simple questions and wanting to learn the basics. So this is a really good tutorial for those of you who are fairly new. If you want to download the script, you can do that on my website, capettidavid.com. If you'd like to support me, you can become a member. You can also share this video, like it, and just let me know what you think. If you have any questions, I'd love to hear them in the comments below. For now, I will be signing out, and thank you very much for watching, and I hope to see you on the next one. Now, at the end here, I will be taking this and creating a render from it. So I'll take this, I'll bake it. So real quick, I'll show you. I'll group this, take this, copy it to the side, rotate it, move it to this, from this corner to this corner. I'll take this one, copy it, rotate it 360, and then moving it back to here. So I'm kind of creating this kind of building form using a curve attractor, and I'll be showing you how I take a capture like this to create a render at the end. All right, so for those of you who want to use some new AI tools, I understand some people are definitely against using AI, but if you're interested in using AI for architecture, check out this tool that I'm using called ReRenderai. It lets you take a quick capture of your design and be able to visualize it so you can apply materials, you can see it in a setting, and it's just a really good use of AI to take your design and place it within a context. You can say cityscape, downtown, glass facade with windows, lighting inside, people walking around, and there's different options that you can pick. But with all of this, you can see that it just gives you different iterations. Are they perfect? Sometimes they're not perfect. Like this one, it looks like it's up on the top of a building, which it could be a use case where you have a building and then you have this on top. But on this one, you'll see that it actually creates a really nice blurring effect around. It shows you what it would look like within a city block with sunset. This one is more of a nighttime render, so you can see the cars going around. I don't know, I just feel like this is such a great tool to visualize designs that is a fairly quick way to do it. Now, I don't suggest using this necessarily for school, saying like, oh, this is what I did, but this is really good for you to be able to get inspired as to what the design or the quick tutorial could become as a real building. So check out these images. I feel like they're pretty high quality. Some of these you can kind of zoom in. If you want to use this tool, you can go to ReRenderai.com. They will have give you the ability to try it out for free. But if you use the code that I'll put here or in the description, you can get some the ability to use this and sign up for a lower price. So if you're interested, I would highly suggest you giving this a shot. And this is what the input was. Give it a shot and tell me what you think. Hopefully it helps you visualize your designs and start using AI for architecture, which will be used more. So thank you very much for being here once again, and I hope to see you in the next one.